So the last bit is 7.6. 2 pages.
Yeah, that's fine. One piece of paper. Someone have to be short.
We are going to go back to some expanding. We're going to revisit something we already know. And we're going to use Pascal's triangle first to expand this. Does anyone know the relationship with Pascal's triangle in regards to expanding? What does it help us with? Okay.
The
Coefficients, the outside number on the triangle. Okay. So remember, go for it. If I were to expand something to power 3, how far do I go down? 3, but technically 4. Okay, good. Because the first row is row 0. Good. So we've got 4 rows. What does that mean? I'm sort of that means we've got term A and term B. We are trying to find out what this looks like without the brackets. So remember, if I have the first term 2m, I'm going to repeat this all the way through. So it's really quick. What power does this 2m have 3? So all we need to do is 3, 2, 1, 0.
0, 1, 2, 3.
And 0, 1, 2, 3.
Oh, yeah, no, I do.
1, where does that go? Here. 3, 3, 1.
For the negative, so you have to alternate positive, negative.
Correct. So we actually do, as Gabe is alluding to, we've got to get into some science, but first, you can actually start them off with positives. Gabe's saying some of them turn negatives. Which ones turn to negative? Okay. You can see negative to power 1, it's got to stay as a negative. So this is 3 times negative 4. 2m squared times 4, m squared. Everyone okay with that? And what's something to power of 0? 1, good. So 2 cubed is 8, m cubed. Done. Going over here. 3 times, what are the numbers that we're multiplying by? 3 times? So 2 to the power of 1 is 2. And then what's the last thing we're going to times by? Negative 4 squared. 4 squared is 16. And 2 negatives make 8. Positive 16. We've got an m to the power of 1. Last bit. 1 times. What's 2 to the power of 0?
0, 1.
1. 4 cubed. 4 cubed. 4 times 4 times 4. Minus 64. Good. Minus 64. M to the power of 0. Anything to the power of 0, it's a 1. Okay. So we have 8m cubed. 3 times 4 times 4 is a negative 48, I think. I missed the positive here. 3 times 2 times 16. 6 times 16. 96. minus 6m, and don't forget negative 64.
Wait, sorry.
Yes.
What are the little powers? Like, how did you figure it?
Okay, these ones here.
Yeah.
So what we do is coefficient A and coefficient B. When we expand them out, what usually happens is at the end, because it's power of 3, we have 2m cubed, 2m squared, 2m1. And the other term goes backwards. Yep. Okay. And we finally get our answer. Now, all I'm saying, for question B, we do something a bit different. Instead of using pascals, we can write it differently. So let me get it in blue. I'm going to erase our coefficients. Coefficient 1, 2, 3, 4. This is just something that you need to get used to. Binomial coefficients. We touched on this in probabilities. And really, the way we do it is you put your n there and you put your row, column and row, or row column. You know what I mean. Therefore, this one here, what position is it on the row? 3. What column is it? 0. This one here, 3, row 3, column 1. 2 and 3 squeezed in there. So that's one way to also write it. The other way, who knows the other way that we write it? So let's do that again. Does anyone know what the other way is? We did it this week. With the C. Okay. 3C0, 3C1, 3C2, 3C3. Everyone good with that? Which means on your calculator, you can type that in your calculator if you want, without going to Pascal. Remember, you've got an exam, CAS and non-CAS. Obviously, if a question like this comes up, you've got Pascal's triangle. In the CAS exam, you just type that into your calculator. It's programmed to calculate it automatically. Any questions? Okay. Yes, sir.
Do we get notes in the non-tech exam?
It's bounded reference, I believe.
Okay.
Oh, in the non-tech exam?
Yeah,
No.
you said there's nothing.
Nothing. Just your pen. Just your pen and your brain. Okay.
Okay.
Any other questions? Let's move on to the last few questions.
I was going to bring it to addition. So we look at sandwiches against some.
Who knows what that means? Is we're summing. Yeah, we are summing. There's another word for it. It starts with S as well.
Sigma.
Sigma. Good. What is that? This looks complicated. It's not. So, there is another way, and you're going to tell me at the end of this question Why is it beneficial to make it look complicated? There's a practical use for this when you're doing your questions. First of all, you can see a lot of N's, a lot of R's, etc., and A's and B's. It's really important you identify everything at the beginning. So what's our N going to be, Tim? 3. What's my A, Amy? 2M. And my B, Perry? -4. It's really important to establish that now. So when we do it, let's not touch the R first. The reason why we don't touch the R, it's like a counting system. It's a machine that starts at R equals 0. But for each one, we know we're going up to 3. So we have 3R in there, which is these two. My A is a 2M. What should I put up here, Hudson? It says N take away R. Therefore, what am I subtracting? 3 minus R. We'll leave the R. Good. And then we've got our B of -4. Once again, to the power of R, which we'll leave alone. Now, what we can do, sometimes you might need to play around with it. How can I split this up? 2M to power of 3 minus R. I want to split the 2 and the M up. If I take the 2 out, what is its power, Emily? 3 minus R. The M here is 8. What's its power as well? 3 minus R. 3 minus R. Okay, you can split them up. If you split them up, you've got to repeat the power. Like so. Okay. Now, we can go a bit further. They might sometimes, in the answers, they might rearrange the order. For example, this -4, it's not really that important. They just put it at the front sometimes. Okay, so right now, we've got a machine that can pinpoint terms in our expansion. What does that mean? Let's now use this for the last 2 questions. It says, question D, find the third term in this sequence. And it says using sigma notation, which is what we've got here. We are now going to focus on our end product, our machine. It started off a bit basic, now it's getting really specific. We can just chuck things into it. It's a machine. So, if I want to find the third term using sigma notation, what R am I going to look for? Is it 0? Is it 1, 2, or 3? The third term. It's a 2. We're going to use 2. When I put it in, we're going to go like so. Actually, we're going to change this to 2. That means a -4 power 2, 2 to the power of 3 minus 2. All my R's are changing to 2. -4 squared, 16, times 2 to the power of 1 times m to the power of 1. Okay? Have I done a mistake? Maybe I have. What am I missing? Oh, I'm missing something really important. What did I miss out on the last term? Yeah. Okay. I forgot to put this guy in. Don't forget the coefficient. So 3. That should be 3, 2. So if we go again, 16 times 2 times n. 3, 2 in your calculator or in your head with the Pascal's triangle. 3, 2 becomes
1. Oh, yeah, sorry.
Because it's great. Yeah, that's all right. It's okay. So look carefully. 96m. Did we get 96m before as the third term when we did the first question?
I don't know.
We did.